So in today's lecture, we'll continue our discussions of differential equation. Till now, we have gone through the differential equation, simple ones, those are variable, separable type, right? Then we have gone through the method of substitution. When we say substitution, it means these are the equations which are reducible to the variable separable type, means this type. And now today we are going to see the homogeneous differential equations. When we say homogeneous differential equation, it means these differential equations are of the form function of xy, right? And they cannot be separated out, means variables x and y cannot be separated, they are in a combined form such a way that neither by substitution also can be separated out. So how to solve this type of equation? The first step we have is substitute y equal to vx. We have this fixed method for solving the differential equations of homogeneous type. And then second step, the substitution for dy by dx, v as it is differentiation of x is 1 plus x as it is differentiation of v will be dv by dx. So these steps, two steps if you follow, right, for sure you are going to get the solution of homogeneous differential equation. Let's see some questions. So the first question which I have is x dy by dx so x dy by dx y plus x 10 y upon x. So here you can clearly see, since y upon 10, right, this trigonometrical function is similar to if this type. So at least one function if you identify, right, which is of this format, then the equation belongs to the homogeneous category. So we'll use our steps. So first step, we have to substitute y is equals to vx. It's already written over here, so I'm not doing it again. Let's make the substitution. Dy by dx gets substituted as dv by dx, y gets substituted as vx, and 10 v. Let's open the brackets. So here vx gets cancelled, and then rearranging dv by y plus x as it is 10v dv by dx x square is equals to x 10v. X gets cancelled once again, so dv by 10v is equals to dx by x. This is nothing but cot v, integrating on both the sides. So integration of cot v is log of sin x. 1 upon x is log of x. Actually it's ln. It's okay if we write as log. So log sin x, log x, and the constant also, let's say if we put it in the logarithmic format, then the log gets removed from both the sides and we get as sin x is equals to xc. This is a differential equation. In case if you keep the constant c as it is, then your equation, this one will be your answer. It depends upon the what type of options you have been given. So any one of them can be your answer. Then let's take a second example to understand the homogeneous type of the differential equation. We have is x plus y cos y right. So this is the question again. Here the y and x cos a trigonometrical function, it is homogeneous, it contains y and x both the terms. So this question belongs to the homogeneous category, and the same substitution once again will use x as it is, y vx cos v, and dx will take it on the other side, x cos v, and dy by dx on the other side gets substituted as v plus x dv by dx. Let's open the bracket. For sure some terms will get cancelled up, x v cos v plus x square cos v dv by dx. So here you can see always the some terms will get cancelled up. In case if they don't get cancelled up, for sure you have done some mistake in the solution. So x gets cancelled and dx by x is equals to cos v dv. Integrating on both the sides, cos v plus c. So ln x sin y upon x plus c. This is the solution of the given differential equation. So here it was cot v. Instead of v, it must be written as x upon y. So log of sin x upon y, this should be. Fine. Let us see the third question to understand the homogeneous differential equation. Right, so here even if you take it on the left and right hand side, clearly you will get to know that the differential equation can't be variable separable. You can try it by shifting, and after that also you can use this substitution. Either in the beginning itself, if you can identify, you can use the substitution, but here you can see the x and y, this complete function, right? It is a collection of x and y in multiplication format, so for sure it belongs to homogeneous type. And even after solving few steps, we get to know that yes, it is a y by x plus y by x whole square. It is a homogeneous type of the function, right? Not possible to separate. So we'll use our substitution. This step number 1 and 2. Dy by dx will be v plus x dv by dx equal to minus v plus v square. So v plus x dv by dx minus v square. So here we can see that the things don't get cancelled out. So let's try to solve further. It's not getting cancelled. So x dv by dx is equals to minus 2v minus v square. So it becomes minus dv by v square plus 2v is equals to dx by x. So here you can, if you want, you can apply the partial fractions method to separate out the variables, and I'll use that. A by v plus b by v plus 2 is equals to 1 upon v plus 2. So this fraction we have separated out. Now plus 2 plus bv is equals to 1. Denominator gets cancelled. Putting v equal to 0, right, implies 2a is equals to 1 and a is equals to 1 by 2, and substituting v as minus 2, we get a gets cancelled, minus 2b is equals to 1 and b is equals to minus 1 by 2. So the integration dv gets separated out. a upon v, and a is 1 by 2, so 1 by 2v plus b minus 1 by 2v plus 2 is equals to dx by x. Let's integrate in terms of dv. So half v becomes as ln v, then the minus was there for complete term, right? So opening up the bracket, it becomes plus half ln v plus 2, and other side 1 upon x ln x, and the constant also let's take it in the ln format, so log gets removed. So here it will become ln raised to the power minus half plus ln v plus 2 raised to the power half is equals to ln xc. This becomes ln, right, 1 upon root v multiplied by square root of v plus 2 is equals to ln xc. Ln gets cancelled. Instead of v, we will substitute y upon x. So square root of y by x plus 2 upon square root of y by x is equals to xc. Or if you want, you can rearrange it further. Otherwise, this is your answer for the given differential equation. Further values are given in this question, so that we can make sure that our equation is correct. We'll try to find out the value of c, and the values are given as x equal to 1, y equal to 1. So substituting these things, 1 plus 2, it becomes 3. So square root of 3 upon square root of 1, that is 1. So it's equal to xc. X is 1. So squaring value of c, we got it as root 3. So let us substitute root y by x plus 2 upon y by x, it is whole square root, is equals to x root 3. Squaring on both the sides, so y plus 2x by y is equals to x square 3. Y plus 2x is equals to 3x square y. So this is a final and perfect differential equation. Here you may have some adjustment depending upon the c, but if the initial conditions are given or some conditions are given, that will for sure make your equation exactly as required by the differential equation. So in this question you can see here x upon y need to be substituted. So whatever standard substitution we have, in that one we'll make some modification. We'll write x equal to vy, and differentiation rather than dy by dx will take dx by dy. So v as it is, differentiation of y is 1, plus y as it is, differentiation of v will be dv by dy. So let's use this substitution, e to the power v1 minus v plus 1 plus e to the power v, and dy by dx we want, right? No, the question over v here we have is dx by dy. So we want dx by dy. Let's substitute. Dx by dy would be v plus y dv by dy equal to 0. Let's simplify further. Ev minus ev dot v plus v plus y dv by dx plus v dot e to the power v, e to the power v, v to the power v plus e to the power v dot y dv by dy equal to 0. So here this term gets cancelled, and then we have ev plus v plus dv by dy. This should be dv by dy. Yes, dv by dy it is. So v plus y plus e to the power v y, and we have dv by dy common. So we have e to the power v plus v, and then we have plus y common, 1 plus e to the power v dv by dy equal to 0. This is v. So let's rearrange ev plus v. Let's shift it on the other side. So y bracket 1 plus e to the power v dv by dy is equals to minus of e to the power v plus v. Yes. And then we have 1 plus e to the power v minus e to the power v plus v is equals to dy by y. Some rearrangements. And now here we can do the integration. So you can use substitution method to solve this integration. Let's put ev plus v equal to t, differentiating with respect to v. So ev plus 1 dv is equals to dt. So this substitution if we use, it becomes dv is equals to dt by t is equals to minus dy by y. So it will be ln e to the power x upon y plus x upon y, and this would be minus ln y and plus let's say ln c. So it becomes, since we have been given initial conditions, we'll solve it further. It would be ln c by y. Ln gets cancelled, and now to evaluate the constant, substituting initial conditions, x to the power 0, so this would be 1, x is given as 0, so c upon 1, so that implies the value of c is 1. So it would be e x to the power x upon y equal to 1 upon y. This is the equation which represents the solution of this differential equation.